As you recall, the control plane in an OpenFlow software-defined network is called the OpenFlow controller, and the OpenFlow controller can manage one or more OpenFlow switches. In a typical installation, an OpenFlow switch will have some initial configuration, which includes the IP address of the OpenFlow controller to which it will connect. An OpenFlow switch can connect to the controller via plain TCP. The default port is 6633. Or an OpenFlow switch can be configured to use TLS, where you would install a certificate on the switch and it would be able to authenticate that it's speaking with the correct OpenFlow controller, and the OpenFlow controller could verify that that switch was authorized to connect to it. Once a switch connects to an OpenFlow controller, there's some initial negotiation where the switch and the controller determine the highest version of the protocol they mutually support. Then they start using that version to communicate. Typically, the OpenFlow controller will request some basic information from the OpenFlow switch, such as how many ports does it have, what kind of ports, what features it supports, and so forth. So the normal configuration is for the OpenFlow switch to initiate the TCP connection to the OpenFlow controller. However, it is common for switches to implement what's referred to as a passive port, where the switch itself would listen for a connection initiated from another device. That's typically used for troubleshooting. So for example, you might have a PC that you use for troubleshooting. There's some commands that are intended to be used in this way. One is called dpctl. It's a command line tool. If you have a PC with dpctl installed, you can initiate a connection to an OpenFlow switch. A switch with this passive port enabled will accept the connection from the PC. Usually this command line utility allows a user to dump contents of the OpenFlow table on the switch. It can also be used to interrogate the switch in terms of its capabilities, and it can even be used to install entries in the OpenFlow table on the switch. Some of the command line utilities that initiate a connection from the PC to the switch, and some of the implementations on the switches for their listening ports also support TLS for security. So in most implementations, a switch can support both a connection to the OpenFlow controller that it initiated, as well as a connection incoming from a PC, say from somebody doing some troubleshooting. In that case, in a normal network environment, the OpenFlow switch would be getting its configuration from the OpenFlow controller, and at the same time, while that switch is live, someone could be troubleshooting the switch by connecting to it, and they could be examining the flow table, they could be looking at statistics, and otherwise trying to determine how the switch is being configured by the OpenFlow controller.